Okay, here's 3.1, number 17. This one was requested by a couple students, so it was worthwhile to do. This is a Newton's law of cooling problem. A thermostat or thermometer reading 70 degrees is placed in an oven preheated to a constant temperature. Through a glass window in the oven door, an observer records that the thermometer reads 110 after half a minute, 145 after 1 minute. How hot is the oven? Okay, so the first thing we need to recall is Newton's law of cooling, which tells us that the rate of change of temperature with respect to time is proportional to the difference between the ambient temperature and the temperature itself. Which I shall go ahead and write like this. T sub s being the temperature of the surroundings, and that just implies that the rate of change of temperature with respect to time is equal to some constant times the difference between the temperature itself and the temperature of the surrounding medium. Now, to make the mathematics kind of prettier, we did this in class, but it's worthwhile to say again, that is exactly the same as saying the rate of change or the derivative of the temperature minus a constant is equal to K times the difference between the temperature and the surrounding temperature of the surrounding medium. The reason why those two are the same is because on the left-hand side, if you break that into two derivatives, one of them is zero. So you just get d capital T dt is equal to K times the quantity capital T minus T sub s, which is exactly what we have in this statement. So they're the same, but now we can go ahead and work with this statement. It's not actually that big of a deal. I think I even mentioned this in our class. I only do this version of it so that students can see that this is like saying dy dt is equal to K times a function y. So if you note, the two functions are identical, which means that we know that y must equal a constant e to the k, k times t, actually, yeah. Okay, and then that will imply, since y is equal to t minus t sub s, t minus t sub s is equal to c e to the kt. Or in other words, the temperature at any given moment is equal to the temperature of the surrounding medium plus a constant e to the kt. Anyway, that's why I kind of remember it this way, is just because it's a little bit easier to derive the formula. So let's go ahead and write down the information they've given us. They've given us that, let's see, time 0, thermometer is 70. And after a half a minute, the thermometer reads 110. And then after 1 minute, the temperature reads 145. Each of these are going to be useful for us because it allows us to kind of figure out what all those constants in our situation are. So I'm going to build this nice little system here. At time 0, we know the output's 70. However, you plug that into our beautiful function there. That's t sub s plus c e to the 0. And so we now know t sub s plus c is equal to 70. Time of 1/2 is equal to 110. So that tells me that t sub s plus c e to the 1/2 k is equal to 110. And then finally, time at 1 minute, or temperature. I keep saying time, but temperature at 1 minute is 145. That's t sub s plus c e to the k. Okay, so those three are going to be nice equations that I'll actually write down in a more clean format. I'll write as 70 minus t sub s is equal to the constant c. 110 minus t sub s is equal to c e to the 1/2 k. And 145 minus t sub s is equal to c e to the k. And you may recall, I'm going to label this 1, 2, and 3. You may recall from algebra how to solve a system involving exponentials, but if you don't, it's through division. So I'm going to take equation 3, and I'm going to divide it by equation 2. If I do that, the left-hand side of the equation would be 145 minus t sub s over 110 minus t sub s. And that is equal to, again, taking equation 3, you'd have c e to the k divided by c e to the 1/2 k. The c's cancel beautifully, and you just have an e to the 1/2 k. And you can actually solve this for k. You can find out what k is here. So let's go ahead and do that. That will imply 2 times the natural log of the, not absolute value, I keep wanting to say that, 2 times the natural log of 145 minus t sub s over 110 minus t sub s is equal to the constant k. Now with systems of equations, we tend to combine 2 of them to see what we can get, and then you combine another 2 to see what you can get, and then you finally combine the last 2. So what we did was combine 3 and 2. Now I'm actually going to combine 1 and 2. So in 1 here, I see what c is equal to, and so what I'm going to do is plug that into 2. So plugging, and there's a lot of other ways you could do this, but I'm just doing it this way. Plugging 1 into 2, we get 110 minus t sub s is equal to quantity 70 minus t sub s, e to the 1/2 k. And actually, now that I see that e to the 1/2 k there, this guy right here, I noticed that I have it up here too. So I've used equations 1 and 2 and 3 and 2 together. So what I'm finally going to do is equate those 2 highlighted versions together. So I guess I really didn't need, and let me cross it out, I didn't need this ugliness right here. What I'm going to do is go ahead and combine these highlighted versions. So I'll grab this guy right here, and I'm going to solve this equation for e to the 1/2 k t, or 1/2 k. Just to get everything isolated, I'll do that right now. Okay, that's what this guy here turns into. And then I'm going to also, on the right-hand side, just equate it to 145 minus t sub s over 110 minus t sub s. 145 minus t sub s over 110 minus t sub s. Now that's a single equation with one unknown, so we can solve that. See, that would imply that 110 minus t sub s squared is equal to 145 minus t sub s times 70 minus t sub s. You do some algebra here. Implies dot 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 implies. So when you solve that quadratic, let's see. There we go. You get the following, which is that the initial temperature is 390 degrees. And if you look up at the very beginning of the problem here, how hot is the oven? That is actually the initial temperature of the oven, right? The oven is the surrounding temperature. And so that's what they're really asking for, is how hot is the oven? It's the surrounding temperature, which is 390 degrees. And there you go.